Hello, everyone, and thanks so much for inviting me to be here today. Hamish, the SBA crew, Bowens. I always think the ultimate compliment is to be asked to do a presentation with builders. So thank you for that, and I hope everyone gets something out of today. So I am Sarah Lebner from Cooee Architecture, and to give you a very quick rundown of my background so you know who's talking to you. I am an architect, and until a couple of years ago, I was the lead architect at Lighthouse Architecture and Science in Canberra under Jenny Edwards, the building scientist. And then a couple of years ago, we moved back to the country to my family farm, and I started Cooee. So over the past 15 years, I guess, working particularly in that team with Lighthouse, we also had construction in-house in the early days. Really had the opportunity to do a lot of testing and optimizing in design, but then also being involved during construction and testing at the end of construction, and then also tracking data after those projects. So it was a fantastic, rich education in what different choices actually mean in terms of results. So what I want to really try and share in this 20 minutes today is a bit of context on how all the solar passive and energy efficiency choices you might make actually fit in with each other and what they mean. Because I find there is just so much information out there. I'm sure you find this too, on what to do and how to perfectly do it. But it's really hard to know what everything means on balance in context. And my absolute passion, even though I hate that word, behind this stuff is trying to help the industry and the public optimize for their situation, because I think the easy part is finding those answers in isolation, right? So how do you do a 10-star home or a passive house? How do you build for net zero energy bills, or how do you build affordably? You can all find answers to all those things in isolation, but the really hard part is where we try to optimize across all these competing factors, which are the reality of every project in real life. So hopefully that's what I can lift the veil on a little bit for you today. Today I'm going to be using the Powerhouse app to do a live demonstration. So this is sort of newly available the last couple of years by an incredible team. And I love what they've done, because they've really put all the power to toggle all these things back in our hands with great immediate visuals, so you can test all of these things. So that's what I'm going to use to demonstrate today. So what the machine is behind this app is that same machine that runs the NathHERS star rating tools. And you may not know that it's actually a very sophisticated machine, possibly one of the best in the world, if not the best. It was developed by the CSIRO and is based on hourly weather data across 69 different climate zones across Australia. So it does model every wall, window, material, gives you that hourly data across all those climate zones. But then they have added in all the bits that you don't get in your star rating. So namely, what kind of appliances and heating and cooling are you putting there? How well are you draft proofing and building that house? And how big is the house? Because your star rating will tell you none of those things. What I can't show you today, that I'm hoping you're already across, but I'll give you a very quick crash course. On our website, under resources, you can find lots of things like this, but I'm assuming everyone here knows the basics of solar passive design. We are in the southern hemisphere, so during the day in winter, the sun tracks lower through the sky, and then in summer, it tracks almost directly overhead of us, and that is what we harness for solar passive design. We want most of those windows on the north so that they are capturing all that massive free heating in the southern part of Australia during winter, but then they're automatically shaded during summer, and we're not creating a little heat box. There we go. There's our little diagram for that one. And the other one I want to touch on today is smaller homes. This is an article I wrote for Lunchbox Architect on 15 reasons why I think smaller homes are better, but just to give us a little bit of context here, this is the average new house size for the top 20 economies in the world, and we are peaking right at the top. Now, it depends where you're getting your data and what you're measuring. We to and fro with Australia and the United States. But the point here is that we're building the biggest homes. And energy star ratings are per square metre. And I'd like everyone to remember that, because it's showing that while we're getting better at doing higher energy ratings, we're also building bigger houses. So the benefits are essentially negating themselves. So the project that I want to demonstrate for you in all this software is this house. It was in Dalgety, hasn't been built, unbuilt. And if anyone knows where Dalgety is, it's right up in the Snowy Mountains. They do get snow there, so this is a challenging climate. It is harder to get good star ratings in a challenging climate, so that's worth keeping in mind today. If we were to move this exact house, that at the end of the day we optimized at about 8 stars. If we moved that to somewhere like Sydney, it would probably instantly be 9.5. So please keep that in mind with context. So it's quite a compact little rectangle. North is essentially up the page, but every site has realities that we have to deal with and work with. So in this instance, we had staggering views off to the west. So you can see we still do have living areas and a lot of glazing off to that west, shaded albeit by a outdoor covered area there. So we'll come back and reflect on this a little bit later. It's essentially a 4-bed, 2-bath. We've got that flexible extra, we sometimes call it a snug room that can be the guest room there. And they had a funny little study nook in the entry, but also had an office out in this garage. And it's only 159 square metres plus 46 square metres for that single garage and office. And they were going to have a carport then next to this. So if we jump back, and here's the 3D. So you can see that summer and winter solstice diagram then. So this is winter solstice, 9 a.m, noon, 3 p.m, sun hitting those windows all through the day. Summer solstice, 9 a.m, noon, 3 p.m, no sun hitting those windows. So that's our great solar passive design optimized there. Okay. Let's jump into the Powerhouse app. So what I've pre-loaded here in our first scenario is some very baseline minimum specs. Now, what I want you to keep your eye in through all of these demonstrations is this graph here and also these numbers up here. So this number here is giving us our star rating. So this first scenario is 4.9 stars. But the other nice metric that Powerhouse have in here is monthly net zero. Very easy to be net zero across an entire year because you're generating heaps of solar in summer. But if you look at this graph, this is where the real nuggets of gold start to tell a story. This orange one here is our winter heating. So massive requirements in winter, right when our solar drops. So the other metric they give you here is how many months net zero are you achieving? That's a nice one to watch. I'm going to keep our solar generation at 6 kilowatts through this whole demonstration, which is this yellow line here, so that you can sort of use that as your visual baseline as we're changing things and we are jumping around. So what have we got pre-loaded in here? I'll show you our envelope. We have got 2 in our walls. We've got a slab on ground with no insulation there. Our ceiling and roof, we've got 4 in there at the moment. We're assuming it's pretty leaky. So this is air changes 15, which I have found is very typical for any kind of existing home that's more than 5 years old, say, or anywhere where they haven't paid attention to just very basic draft proofing. And then the windows that we have in here at the moment are single glazed aluminium with clear coatings. So that's what's getting us to our 4.9. So just to pause on that fact for a moment, 4.9, still way better than all of our housing stock in Australia. So this is one of my favourite diagrams done by The Guardian, showing our existing housing stock in Australia. Of course, it's still an estimate, but look at the battle we face here. 72% of homes in Australia are 1.8 stars or less. So just by putting in very minimum, probably under minimum specs on this first run on this house, but having it face the right way, getting to 4.9 stars is kind of amazing, just using that solar power thing. So 4.9 stars, it would already be close to the top 5% of homes in Australia. So there's some context there. The other part the star ratings don't show us, though, is how we're heating and cooling, right? So if we assume we've got 4 occupants in the house, but at the moment we're heating it with electric resistance heating, ducted reverse cycle, and resistance electric hot water, big energy generation. Let's jump this one up to wall-mounted split system. Massive drop in energy use. We'll see a tiny one just from changing to ducted to split systems in summer. And then our electric resistance hot water to heat pump down. So you can see just what a massive change that makes with the exact same home, but powering it differently. Okay, now let's play with some scenarios. So hang on, just let me take this back so you've got that same baseline to compare to. Let's jump in to our walls and we'll make this 2.5 and 2.5 here as well. Our floor, we'll leave that for now. We'll chuck in 5 in our ceilings. And let's take our air tightness down to 8 to 10, which is the amount that your certificate, your ER certificate, assumes you're going to achieve. That's what you're meant to achieve just through basic good practice. So we're at 5.3 there. Let's go through and just make these double glazed aluminium, still clear. Take that down. So 6.2 is where we end up there. Maybe let's come back and have a look at that slab. We're in a cool climate here. So let's assume that we're doing some under slab insulation and some slab edge insulation. We're up to 6.8 there. And I'll just note here, when we modelled this one a while back, we didn't have internal and external walls in here yet. Now if you go in, you have the internal walls and you can add your internal wall insulation in there, which we usually do at 1.5. So 6.8, right? Really close to that minimum 7 stars, and we've just done some pretty basic stuff. If we come back into this diagram, if we're getting up close to 6 stars, we're getting to the top 20% of homes. For context, let's jump back in, see what happens if we change those systems up to be more efficient. 10 months net zero there, okay? So we're doing pretty good. Now what we tend to do that takes it a little bit further, which you may also be doing, let's change those windows to something thermally broken. We do a lot of UPVC. And if we jump that down, there we are at 7.5 stars. And what works really well in our cool climate is low E, pretty cost effective, a low E film on the windows, which takes us down a little bit more. We're sort of somewhere around there that we're typically seeing. So we're at 7.6, we're well over compliance. We haven't done anything too crazy yet. You can see that we have reached net zero there, easy, right? But the other thing I want to show you is our air tightness here. So 8 to 10 is that sort of default. You're not doing a sloppy job, but you're probably not quite across exactly where air leakage weaknesses are and how to cork and do that properly. So if we just get to about 5, which is what we aim for, still using standard construction. And in fact, one of my favorite resources on this is the Sustainable Builders Alliance. There's their checklist, their tool, I think it's called, for high performance construction. We provide it to all our builders, and it speaks about how to cork and draft proof effectively just at the plasterboard level. So we're not talking about extra membranes and sort of passive house style construction just yet. So down to 5 as a bit of a sweet spot, massive jump up there to 8.2. So I'll go back, 7.6, 8.2. Huge leap, and very little cost in the extra attention to detail there on just good detailing at the plasterboard level and corking and having, IC4 rated downlights, back dampered fans, good ceiling windows, draft proofing on external doors, and corking and sealing around your architraves and pelmets and skirting, and even corking across the top of the door where the painter might not see, but it makes a draft proofing difference. What happens then if we do go tighter and we're perhaps looking at getting into that passive house style construction? Sorry, I should have this expanded so you can see that difference there. Let me go do that. So even though we're going 7.6 to 8.2, because we've made those appliances really efficient, you're not seeing those massive gains we had on the really inefficient appliances. 5 down to 2, 8.2 to 8.5 stars. So, that still is a noticeable difference. And then comparing 5 to 0.6, the passive house standard, 8.2 to 8.7. So we're getting another half star there. But as we all know, in that reality we're talking about, you do really have to have that conversation about what is the extra budget cost to be achieving that extra level of detail, and are those gains right for this client and this scenario. Our clients are usually aiming for that net zero operation use with a fairly modest solar system. And what I really like to demonstrate in these is how cost effectively you can get to that if that aligns with your client and your goals. So a few extra little bonus points of interest. Let's now make this 8-star home be very inefficiently heated and cooled. What happens then? Still massive. So this is a really important point. I think you can have a 9-star home and you can make it massive and heat it really inefficiently and basically undo all of the work there. So I love demonstrating that one. Other little things that you can do in the app, you would have seen colour. Colour really affects very little. I think it's more important when we're talking about urban heat island effect. This is a rural project. If we change our roof from light to dark here, 0.1 of a star difference, it's really, it's not the elephant in the room, let's say that much. You can go in and use the tool to sort of change windows and change shading and things like that. You can make sure you've got your seasonal shading on your east and west. If you're in retrofit land, because let's come back to this one and remember, so when we got up to 7 stars, you're in the top 1% of homes really already, just doing those sort of easy to achieve things. But we have all of these homes here that really need retrofitting. Perhaps the ones that are up further north, we won't get into the debate about whether you should take the same approach with them. We are all down south here today. We know there's a big retrofit job to do. So there is a tool here if you're trying to help clients decide what their cost to upgrade is and what their payback is. You can also use this tool. This one's not going to show us anything of interest because it's not set up, but you save an existing house, you save 2 different versions, change your specifications, and then it can show you the benefit of each decision as you go through. You can sort of generate some reports. And some other things of interest, we've got our form complexity here. So a really nuggety house is always going to perform better. You know, when you're cold in the middle of winter, you do this. You don't sort of be a starfish out like that. So limiting our external area. Even though this is a rectangular nugget, it still only gives us a moderate. And I've been told that if we want top marks on form complexity, it would actually have to be 2 stories so that you've got that efficiency vertically as well. So moderate's pretty good. And the area of glazing is a really important one as well. So our area of glass to floor area ratio, we're coming in at 29%. Now you'll see different numbers sort of bandied around here. Some people say sort of 24, 25. We usually aim for 27. And on this home, we actually pushed a little bit higher than we normally do, up to 29%. So that's another really big factor. Even good thermally broken double glazed windows like UPVC windows are still transferring heat 7 times faster than an insulated, standard insulated brick veneer wall. So windows are a weak spot. I'll come back to this floor plan. So now that you've seen the numbers, you can have another squiz at that. While I finish by saying, importantly, I'm not associated with Powerhouse. I just really, really, really love their tool, and we work with them on all our projects now because it's really empowered our communication and authority to clients as well. We don't have to do that really painful, slow back and forward with our energy assessor to get the answers and test different scenarios. You can do most of it in the app here. And just the importance of retrofit. Again, I know I've talked about a new build here, and new build is easy to talk about and easy to achieve those results, but you can still achieve great things with retrofit, and this kind of modelling and approach and all of the sort of priorities I've talked through today, particularly draft proofing and upgrading appliances, as you can see, they're doing the bulk of the grunt work as it is. I hope that makes sense, and I look forward to some questions. Thank you so much for your time.